In this question, you have a stone that's dropped into a pond and there will be circular waveforms or ripples that's been created. And you should know that all these circles that you have here, they are called wavefront. And I hope you can still remember the definition of wavefront is an imaginary line that joins all identical. So identical means if it's joining all the crests, then it's all crests, or if it's a trough, all trough, okay? And they are in phase, meaning to say they have the same speed, same direction, or same displacement, okay? So take note of that. To make it clearer, I can actually draw this. The wavefront are joining all the crests. So the crests coincide with the circles. So you can see that this wavefront is joining all the crests, and this another wavefront that's joining the adjacent crest together. And of course, you must know that the distance between two wavefront, that is your wavelength. So if I assume y to be my crest, that means to say the x here, which is in between two wavefront, that will be a trough. All right. To help you visualize, let's maybe draw the cross-sectional of the water wave here. So this is the water wave, and if y is the crest, let's assume y is here, then your x after another crest, then x will be here. There's your trough, which is the lowest point of the wave, and y is the crest, the highest point. So if you know that, option D and C and D will be wrong because they stated that x and y are both at the highest or the lowest, okay, which both are wrong. They are not in phase. Now let's take a look at option A. It says that x and y are vibrating in the same direction at any instant. In other words, what they are trying to say is both are in phase, same direction, same speed, same displacement of velocity. But as I mentioned, you should know that y is the crest. The next moment it is going down and this is going up, so the direction is basically out of phase. Okay, when will it be, just to recap a little bit, when will it be in phase? If y is in phase with another point, it will be here. Okay, if they are one wavelength apart, both points will be in phase. Let me give you another example. Okay, so if it's trough here, another point will be here. They are in phase, one wavelength apart. And if I have to draw the undisturbed position, what if I have a point that's over here? Another point that's in phase will be one wavelength apart. Now, definitely not here, because these 2 points that you have here, they are half a wavelength and both will be out of phase. All right, take note of that. So A will be wrong also. So the only answer will be B. They have the same magnitude, because magnitude, you should know that is is basically the distance from the undisturbed position to the highest point, or over here. So in both position, the amplitude will be the same. So I hope you understand the question now. Thank you.